Hello again, my name is Laurel Swisher. For my last podcast of this semester, I will be discussing how global warming is affecting wildlife and all types of environments. My first presentation was about biodiversity loss in general, and my most recent one was about fracking, where I talked quite a bit about global warming. Today, I plan to hone in further on a few of the topics I mentioned in my previous videos. I will start off with a summary of what global warming is and how it is happening. It is under the much larger umbrella of climate change, which categorizes all shifts in climate that have been recorded as long-term trends. Global warming is considered one of the many symptoms of climate change. Just as the name indicates, it can be defined as the overall rise in Earth's temperature. The primary cause of this heating is the growing concentration of greenhouse gases in the Earth's atmosphere. Carbon dioxide, methane, and nitrous oxide are a few examples. These molecules are generated in mass amounts by human activities, especially through the burning of fossil fuels. Issues like these began during industrialization. In short, as they build up, more and more heat becomes trapped and the Earth continues to become warmer and warmer. This graph from NASA is one of my favorites. Rather than directly displaying the change in temperature, it shows the concentrations of atmospheric CO2 over time. Limited further analysis and reasoning was needed to construct a graph like this, as the data preceding modern times came directly from ice core compositions. I find this helpful as you can make your own interpretations without it being explicitly stated in the graph. We can clearly see that there has been a spike in recent times, and this is one of the factors that correlates to global warming. As I will discuss in this video, more than just the heat itself can impact wildlife. It is established that a temperature increase is problematic, but what does it actually amount to? I will break down some of the effects on various species and ecosystems, starting with marine life. Ocean acidification goes hand in hand with global warming. The rising levels of carbon dioxide do more than just trap heat. When large quantities of CO2 molecules are dissolved in water, they cause the water to decrease in pH. This has several negative effects on ocean habitats and their inhabitants. For one, as this diagram shows, increased acidity reduces the availability of carbonate ions within the water. Carbonate is necessary for many marine organisms as it is an important component for building protective and structural elements. Sea stars, mollusks, and even some plankton and coral are just a small portion of the organisms that are affected by ocean acidification. This can result in calcium-containing elements becoming smaller and weakened. Furthermore, pre-existing shells have been observed degrading due to minerals dissolving from the acidity. Overall, affected populations are growing smaller in size and number. This is not only harmful to animals directly requiring carbonate, but it also impacts the remainder of the food web. As we have been reminded since grade school science classes, a decrease in any species of a food chain can throw an entire ecosystem off balance. Recovery from temporary issues is typically feasible, but this trend indicates a steady downhill direction. The combination of increasing acidity and temperature of the oceans is devastating to coral. Most coral are not colorful on their own. They have a symbiotic relationship with various species of algae that give them these vibrant colors. When the coral becomes stressed due to the rising temperature, for instance, they expel this algae. This causes them to appear bleached. Also, as the acidic water eats away at the skeletons of the coral, reefs become increasingly more susceptible to erosion. These examples are only a fraction of the many impacts global warming has on marine organisms. Global warming is a massive contributor to habitat loss. I discussed the depletion of coral reefs, but there are many more examples. As the average temperature of the planet rises, ice continues to melt. This is an issue not only because it decreases the area animals such as seals and polar bears can reside in, but it also increases the rate of global warming even more. Large sheets of ice reflect sunlight, while dark ocean water absorbs additional heat. As more and more of the ice becomes water, more and more of the sun's energy is absorbed. This amplifies all of the issues I'm discussing. In addition, this process causes sea levels to rise dramatically. This is detrimental to coastal and freshwater habitats. Most notably, The overall depleting surface area of ice is rapidly driving species into endangerment, and some may soon face extinction. As the global temperature continues to rise, natural disasters are becoming both more extreme and difficult to predict. There are several causes of this increase in natural disasters. As I covered before, ocean temperatures are significantly warmer than they were a few decades ago, and they're continuing to heat up. These conditions foster a perfect environment for powerful hurricanes to develop. In other areas, conditions are becoming hotter and drier. When they remain in this state for extended periods of time, it provides the perfect breeding ground for wildfires to start and grow out of control. All natural disasters have the potential to be deadly to wildlife. They can inflict harm directly or to their surroundings. When a habitat becomes altered, surviving animals are often forced to vacate. I will discuss this further in later slides. As global warming causes events independent of wild animals to begin earlier or later than usual, many species are forced to follow cycles that are not natural for what they have evolved to do. In other words, this trend is much faster than what evolution can keep up with for most organisms. One major factor in this is the timing of resource availability. For instance, plants tend to bloom earlier because the weather typically gets warmer earlier in the spring season than it has in previous years. This is just one example of the events that can contradict with organisms' biological clocks, including a variety of migratory birds. In combination with the rising temperatures, unnatural changes like these can cause many species to begin their activity periods in various cycles at different times than previously recorded. This is yet another symptom of global warming that can affect species and entire food webs and destabilize whole ecosystems. An overall consequence of life systems being thrown off is the alterations to reproduction. Each component in reproductive cycles has the potential to be interrupted by these factors. Ultimately, fertility and survival rates for various populations are continuing to decline. When an animal determines that its current habitat is no longer sufficient, it may be pushed to relocate. Populations of a variety of organisms have been observed changing locations, especially to higher altitudes. They may also be forced into a new location after their habitat becomes entirely destroyed or significantly altered. This can affect species both in water and on land. The diagram here represents an example of how the distribution of aquatic species can change as the sea level rises. Over time, a literal uphill trend of various plant and animal species have been recorded. Such animals include mammals, insects, amphibians, and birds. This is not a conclusive list, but it goes to show the vast range of those affected. The majority of organisms have a distinct temperature window that they are able to thrive in. In many cases, the climate and the elevation populations have previously lived in has surpassed this temperature range. Some are progressing upward quicker than others. Higher altitudes are also less suitable for some species than others, as there are downsides such as the lower levels of oxygen available. Populations that are either unable to acclimate to the rising temperature or move elsewhere generally have a low rate of survival. Expanding distribution promotes increased spread of disease. Ticks, for example, often thrive in warmer temperatures. Existing in an active, disease-transmitting state for a longer period of time over a wider range increases the probability of passing that disease along. This occurs in combination with the weakened immune systems of many animals due to stress. Invasive species also have greater opportunity to expand their ranges under these conditions. In many cases, the reason these species are invasive in the first place is because they are better suited to any changing conditions than native species are. Therefore, when it gets warmer, the risk increases. Also, with less competition due to natives vacating the area, the risk of invasive species thriving is even higher. Overall, situations like these are incredibly harmful to native plants and animals. Wildlife wander close to and even into human establishments for a variety of reasons, including in search of a more suitable habitat or resources. This may seem harmless in some cases, but there are both large and small cases of human-wildlife conflict every day. Deer entering roadways is one devastating example that most people are familiar with. When wild animals are in search of necessities, food or shelter for instance, there commonly becomes an overlap in human and wildlife territory. This often leads to human retaliation, as they can be viewed as pests. Scenarios such as bears getting into trash or rodents entering buildings are common examples of this. These situations are typically negative for both parties, and they have led to an overall increase in stress for wildlife. Many cases even end in mortality. The most effective method of solving these problems would be to start at the root, the causes of global warming. Unfortunately, this is the only actual solution that would do more than serve as a temporary patch. If policies were enacted that cracked down on emissions and other contributors, we could slow the damage enough that the Earth could better keep up with it. Unfortunately, if we continue at the rate that current policies indicate we will, species will continue becoming endangered and extinct. It is likely that humans will die out before the Earth is able to recover thousands of years later. Methods of minimizing effects on wildlife for now include protecting the habitats that remain stable and restoring others. This largely includes removing invasive species and replacing them with native ones. It is also helpful to monitor trends in order to predict outcomes and make sure areas will be equipped with necessary resources in the future. When the future of a habitat does not seem feasible, we can interfere to promote the safe passage of a population into another area. Additional adaptive strategies are becoming increasingly important. Structures that lessen wildlife-human contact as they expand their territory are helpful. Some include barriers and wildlife corridors. In some cases where contact with humans is not necessarily harmful for a species, individual people can make a huge impact. One example of this is the amount of people who have begun providing plants for monarch butterflies to lay eggs and feed on. This occurs in backyards and even on rooftops. As always, we need to continue spreading awareness and educating each other about these issues. The more people who care and speak their minds, the more likely change is to occur.